Welcome back. This is part 3 and we'll be discussing about the interfacing of LEDs. LEDs are light emitting diodes and they are usually used to display a status in an embedded system. For example, in a general embedded system, we may be using two LEDs. We may have a green LED and a red LED. Whenever the system is working properly, this green LED will be turned on, and whenever there will be a fault in a system, we may turn on this red LED. So how to connect LED to microcontrollers? One thing you should remember before using any electronic component is to check the specification sheets of that component. Specification sheets usually tell us a lot of things about that component, about the component we are using. Particularly, it tells us about the operating voltage, and operating current of that component. You all may have seen an LED. An LED usually has two pins, an anode that is connected to the positive and a cathode that is connected to the ground, or that is connected to the 0 volts. Let me show a picture of these LEDs. These LEDs, as you may be seeing, usually come in different colors, and also they may also come in different diameters. The ones you are seeing are 3 mm LEDs. So these operating voltage and operating current of an LED usually depends upon the color of the LED, and also it varies according to the diameter of the LED. If you Google about the specs of a 3 mm red or 3 mm green LED, you will find something like that. For example, for a green LED, you may find something like this. It will have an operating voltage of 2.2 volts and a operating current. You may see something like maximum forward current of 20 milliamperes. So what will happen if we connect this LED direct to a microcontroller? Since our microcontroller gives 5 volts, any pin of microcontroller P2.0, I am connecting an LED to this. The other side of LED I will be connecting to ground. So whenever there will be a high here, so this LED that is connected to P2.0 should turn on. Actually, what will happen, 5 volts will come across this LED. But this LED only needs 2.2 volts and it only needs 20 milliampere of current. Let's calculate how much current goes through it when we connect it to 5 volts. For that we have I equal to V by R. That means first we have to calculate resistance of this LED. Since we have its operating voltage and operating current, V is equal to IR, and from that we can calculate R LED will be V by I. That means 2.2 divided by 20 into 10 raised to power minus 3. If you can calculate this will approximately come, or let me calculate it, this comes to 110 ohms. So the resistance of this LED is 110 ohms. So when we connect to this 110 ohm resistance to a 5 volt source, we connect a 5 volt source across this 110 ohm resistance. The current which is going to pass through this LED will be 5 volts divided by 110. That is approximately 0.045 amperes. That means 45 milliamperes. But the maximum forward current of the LED was only 20 milliamperes. This current will eventually heat up the LED and it will eventually burn. So it's not advisable to use the LED directly with the microcontroller. So what we do, we use a current limiting resistor in series with the LED. So the configuration will be something like this. We have the microcontroller, maybe P port 2.0. We connect an resistor to it, and then we connected this LED, and then to ground. So whenever there will be a high here, 5 volts will come across resistor and across this LED, and depending upon the value of this resistor R, and depending upon the resistance of this LED, some amount of voltage will come across this resistor and some amount of voltage will come across this LED. What is desired here, that only 2.2 volts should come across this LED. So using this information, we can calculate the value of this resistance. Of course, this 2.2 volts is for green LED. Green LED, 3 mm green LED. If we are using any other LED, we should first know its operating voltage and operating current. Here the operating current is 20 milliamperes. We have already calculated its resistance as 110 ohms. So this simply gives us a voltage divider circuit like this. We have a resistor R. We don't know the value of this resistor. We have another resistor here, that's of 110 ohms, and this is connected to a voltage supply of 5 volts. So the voltage across this is desired to be 2.2 volts. So using the voltage divider formula, I can write like this: 2.2 equal to 110 multiplied by total voltage 5 divided by total resistance 110 plus R. That means R equal to 110 into 5 divided by 2.2 minus 110. That gives me a resistance of approximately 150 ohms. So to connect a green LED of 3 mm dia with 2.2 volts of operating voltage and maximum forward current of 20 milliamperes, I have to use a current limiting resistor equal to approximately 150 ohms. That will actually limit the amount of current that flows through this resistor. So interfacing an LED is very easy. We just have to connect a current limiting resistor in series, and the value of this resistor will depend on operating voltage and operating current of LED. And the operating voltage and operating current of LED actually depends upon the color of the LED and also the diameter of that LED, and that we can always have from the specification sheets of that LED. That's it about the interfacing of LEDs. In next video, we will discuss about the interfacing of a LCD, liquid crystal display. Thank you.